In this segment, I wanted to quickly show you why sign bit extension works. Meaning, suppose, let's say, short integer is -1, and you have another integer I. Somewhere down the line, I is assigned to S. Why would be the value of I is also -1? That's the question we are trying to answer in the segment. All right, let's try to prove why I is -1. Okay. Instead of proving this very specific case that I being -1, I'm going to prove a much general case. Okay. Let's say I have a variable A, which is made of W bits, right? That means the first bit will be A W -1. The next bit will be A minus W2. And this is in binary, of course. Each A W minus something is either 0 or 1. Okay. Now I'm going to extend this by only one bit. Okay, so I'm going to form a new number B, right? So I will have the same most significant bit repeated 2 times. That's basically 1 bit extension. I'm just extending it by only 1 bit. Okay, so now I'm claiming that the value of B is same as value of A. So I'm going to prove that A equal to B. Okay, how can I prove that? So in order to prove A equal to B, we can consider the very simple case first. The simple case is that suppose let's assume A W -1 is 0. Okay. Well, in that case, it's easy because if we put zeros in the front, the value doesn't change, right? I have more zeros in the front. That means B is still preserving the old value of A. So no difference between B and A. But that's easy to prove. So I will not spend much time on it. Let's consider the case that A W -1 is not equal to 0. Okay, that's where the interesting stuff is. Okay, so if it is not equal to 0, okay, that means it must be 1 because we have only 2 possibilities, 0 or 1. When the most significant bit is 1, we assume that the number A is a 2's complement number. Okay, so what is the binary representation of A? And how do we interpret that in terms of decimal representation? So we take, consider number A now, okay? Number A is just made of -2 power W -1 plus 2 power W -2 A W -2, okay? All the way until 2 power 0 A power 0. This is how we convert a binary number back to a decimal number, right? Okay. All right, let's consider the number B. Number B is easy to write as well. The first position must be always minus. So that means the first position is just -2 power W, A W -1, and then 2 power W -1, A W -1, okay? And the rest is clear for you. Okay, let's pay close attention to the first 2 terms. What can we take common? Suppose we take minus A W -1 as common, right? We will be left with 2 power W minus 2 power W -1, right? I'm just taking A W -1 is common. And then we have all our other terms as it is. Okay, 2 power 0, A power 0. So what is 2 power W minus 2 power W -1? That is nothing but, I can write it here. 2 power W minus 2 power W -1 is, interestingly, 2 power W -1 into 2 power W -1. Okay. Remember, this term is just 2 power W -2 A -2, exactly whatever you're seeing in A, right? A also has exactly the same binary representation. So we end up in A. So even though we extended the number B by 1 bit, we got back the number A. Okay, that's basically the idea of this proof, that if we extend a number by a bit, you get the original number. That means if you extend by any number of bits, you will get the same value. Okay, we are taking the most significant bit, right, of A, and you extend it by only one position. That means we write it here as well. And if we now take B as our A and extend it by 1 more position, we should have the same value B. Okay, by induction, you can see that we can extend it by any number of positions and the value will be the same. Okay, that's basically it. Thank you for your attention.